Hello everyone, welcome to Statistics and Probability class. Our topic for today is all about probability distribution of discrete random variable and its properties. Our objectives are to illustrate the probability distributions and its properties. Then we compute probabilities corresponding to a given discrete random variable, and to construct the probability mass function of the discrete random variable and its corresponding histogram. But before that, will you please open your browser and let's play Kahoot. The activity is composed of 10 item questions. You are given 10 or 15 or 20 seconds to answer each, depending on the category. I'm going to give you 5 minutes to answer the questions. Here is now the link. Timer starts now. How did you find the activity? Is it interesting? Did you enjoy the game? I hope so. I understand if you got low scores. After our discussions, we will go back to the game. You will play again. So you need to pay attention during our discussions. So let us start with the definition of discrete probability distribution. A discrete probability distribution describes the probability of occurrence of each value of a discrete random variable in a situation. For example, if 2 coins are tossed, the possible outcomes are head-head, head-tail, tail-head, or tail-tail. If x is the random variable for the number of heads, so we will represent that in a table having 2 rows. The first row, you will write down all the possible outcomes. So we have here head-head, head-tail, tail-head, and tail-tail. For the second row, it is all about the value of random variable, which is the number of heads, since our random variable x is the number of heads. So we will just count the number of heads in the outcomes. So we have here 2 heads, this one has 1 head, and this one has 1 head also, and this outcome has 0 head. Next, we will get its probabilities. So the probability of no heads or getting no heads is equal to, we have here 0, it is only 1, so we have 1 out of 4. 4 represents the number of total outcomes. So we have here 1, 2, 3, 4. That's why the denominator is 4. Next, we go to the probability of getting 1 head. We will check on the table the probability of getting 1 head. So we have here head, 1, and another 1. So we got 1 plus 1, 2. 2 out of 4 outcomes, or we simply write that as 1 over 2. Next, we will get the probability of getting 2 heads. So in our table, we can see the outcome that has 2 heads. So we have only 1. So we write that as 1 over 4. Then we will make a table of the probability distribution. So the first column, we have number of heads, which is x. The 0, 1, and 2, we got it from this row, the value of random variable x, which is the number of heads. We just arrange it in ascending order. So we have 0, 1, and 2. And their probabilities are 1/4. We got it from here. We have 1/2 and 1/4, respectively. Okay, do you have any question? Okay, we go to the next. Construct a probability distribution for rolling a single die. Okay, if you will imagine that a die has 6 faces, and this is the sample space. If we're going to roll a die, there is a possibility that 1 dot will come out, 2 dots, or 3, or 4, or 5, or 6 dots if you're going to roll a die. Then, each outcome has a probability of 1/6. And then we will make a table. First column, we got the random variable x. For the outcome, we have 1, 2, 3, 4, 5, and 6. And the probabilities are the same. So we have 1/6. They are all the same. Okay? Next, we go to the properties of discrete probability distribution. Number 1 property, the sum of all probabilities should be 1. In symbol, we write that as the summation of p of x is equal to 1. So that means that the sum of all the probabilities must be equal to 1. That is number 1 property. So let's have an example. We have here the table, a distribution. So we have number of heads, 0, 1, and 2. This was the example in the previous slide. And we have here the corresponding probability, 0, probability is 1/4, 1, the probability is 1/2, 2, the probability is 1/4. We will check whether the probabilities is equal to 1. So the probability of x is equal to 1/4 plus 1/2 plus 1/4. Would that be equal to 1? Yes, it is equal to 1. If you're going to add all of them, that is equal to 1. So it satisfies the first property. The next property should be the probabilities should be confined between 0 and 1. So in symbol, we write that as the probability of x should be equal to or less than 0, and it is equal to or less than 1. Okay? Or the number must be between 0 and 1. 0 and 1 are included. Okay? We will check. Here is the probability of 0, which is 1/4. Is 1/4 a number between 0 and 1? Yes. Is 1/2 a number between 0 and 1? Yes, also. And so, with the probability of 2, which is 1/4, they are all numbers between 0 and 1. So, it satisfies the number 2 property. Therefore, this distribution is a discrete probability. Okay, do you have any question? Next, let us determine whether the distributions is a discrete probability. Remember that to determine the distribution is a discrete probability, we are going to check whether the two properties comply. Okay? So we have the first property that the summation of the probability of x is equal to 1, and the other one is the probability of x must confine between 0 and 1. So it must be greater than 0 but equal to 0, and it must be equal to 1 or less than 1. So let's have letter A. Okay, so we have here the distribution. We will check whether it satisfies the two property. We will check on the probability of random variable 3. As we can see here, the probability is negative 0.3. Is this number a number between 0 and 1? Okay, no, it doesn't satisfy the second property. So this is not a discrete probability distribution because of the presence also with a negative sign. And negative signs, they are numbers which are less than 0. So this is not a discrete probability distribution. Okay, we go to the next. We have here letter B. This is our distribution. Check on the probabilities of each random variable. So we have here random variable x, 1, 2, 3, 4, and 5. And these are their corresponding probabilities. So we have 3 over 10, 1 over 10, 1 over 10, 2 over 10, and 3 over 10. Check if these probabilities are equal to 1 or less than 1 or equal to 0 or greater than 0. Okay, so we have 3 over 10. Is this number in between 0 and 1? Yes. How about 1 over 10? Yes, also. How about 2 over 10? Yes, also. And how about 3 over 10? It is also yes. So it satisfies the second property. Now we're going to check whether the sum of its probabilities is equal to 1. So we have here the summation P of x is equal to 3 over 10 plus 1 over 10 plus 1 over 10 plus 2 over 10 plus 3 over 10. As you can observe, the third denominators are all the same. So therefore, we just add their numerators. So we have 3 plus 1, we have 4, plus 1, this is 5, plus 2, this is 7, plus 3, this is 10. So we have 10 over 10, and 10 over 10 is equal to 1. So therefore, distribution letter B is a discrete probability since it satisfies the property 1 and the property number 2. Okay, so do you have any question? Yes, it is a discrete probability distribution. Next, we go to number 3. Suppose 3 coins are tossed. Let y be the random variable representing the number of tails. Construct the probability distribution and draw the histogram. So we're going to construct probability distribution, and we will draw the histogram of that distribution. So we have 3 coins here are tossed. So this is now our table. The first row represents the possible outcomes. These are the outcomes. And the second row is the value of random variable y, which is the number of tails. So we will count the number of tails. For our first possible outcome, we have 3 heads. There is no tail, so this is 0. We have head, tail. There is 1 tail, so this is 1. Next outcome, head, tail, head. The number of tail is 1, so we have here 1. Next outcome, we have head, tail, tail. We have 2 tails, so the random variable is 2. Next, we have tail, head, head. We have 1 tail, so we write 1. Then tail, head, tail. We count the number of tails, we have 2. And the next outcome, tail, tail, head. The number of tails are 2. That's why 2 is written here. And the other one, outcome, is tail, tail, tail. So we have 3 tails. That is why random variable 3. Then we will construct a distribution. We will just arrange in ascending order this random variable. So we have here 0, 1, 2, and 3. Okay, their corresponding probabilities are, let us check. So, for 0 number of tails, we only have 1. So, we will write 1 over 8. Where did we get 8? The number of outcomes, the total number of outcomes are 8. So, we have, let us check. 1, 2, 3, 4, 5, 6, 7, 8. So, there are 8. So, we have 1, 0. We have 1, 8. Next, we will check on 1 tail. The probability of random variable 1. We will count. So, we have 1, 2, and 3. So, we will write here 3 out of 8. Next, the random variable 2 tails. So, we have 1, 2, and 3. So, we write this as 3, 8. And then next, the number of tails of 3, we will check. So, we have only 1. So, we have 1 over 8. Then, we will construct the histogram. Okay, we're going to draw the histogram out of this distribution. So, we have here, on the x-axis are the random variable y. And the y-axis represented by probabilities. So, the probability of getting 0 tail is 1/8. Okay, we will shade until 1/8. The probability of getting 1 tail, we have 3/8. So, we will shade until 3/8. And the probability of getting 2 tails, we have 3/8 also. Shade until 3/8. And the probability of getting 3 tails, we have 1/8. So, you have to shade until 1/8. So, this is now the histogram of this discrete probability distribution. Do you have any question? Okay, we go to the next. The following data show the probabilities for the number of cars sold in a given day at a car dealer store. So, we will represent that. These are the given, the number of cars, the random variable x from 0 to 10. And then beside them are the respective probabilities or the p of x. Okay, then we will find out this one. Letter A, find the probability, and the condition is x must be equal to 2 or less than 2. So, which are the numbers that belong to those conditions? So, we have here equal to 2. Of course, 2 is included. And what are the numbers below 2 are 0 and 1. So, these are the 3 probabilities or the random variable 0, 1, and 2. So, we will add the probability of 0 plus probability of 1 plus probability of 2. Probability of 0 is 0.100 plus probability of 1 is 0.150 plus probability of 2, which is 0.250, and that is equal to 0.500. So, the probability of random variable x, which is equal to or less than 2, is equal to 0.500. Next, for letter B, find the probability of x wherein x is equal to 7 and greater than 7. So, what are the numbers? What are the numbers that belong to this? Okay, let us check. So, 7 is included, and the numbers which are greater than 7 are 8, 9, and 10. Okay, so we have here the probability of 7 plus probability of 8 plus probability of 9 plus probability of 10. Probability of 7 is 0.50 plus probability of 8 is 0.040 plus probability of 9 is 0.025 plus probability of 10, which is 0.015. So we will get the sum of that would be equal to 0.130. So the probability of random variable x, which is equal to or greater than 7, is equal to 0.130. Next example. So we have letter C. Find the probability, and the condition is x confined between 1 and 5, meaning random variable x is equal to 1 and which is greater than 1 also, and it is equal to 5 and less than 5. So which numbers are included in the given condition? So we have 1 is included, 5 is included, and between them. Okay, so we have the probability of 1 plus probability of 2 plus probability of 3 plus probability of 4 and plus probability of 5. Therefore, we have probability of 1 is 0.150, probability of 2 is 0.250, plus probability of 3 is 0.140, plus probability of 4 is 0.090, and probability of 5, which is 0.080. So the sum is equal to 0.710. So therefore, the probability that is confined between 1 and 5 is equal to 0.70. Do you have any question? No question? Okay. Will you please open again your browser and let's play again Kahoot. Okay, same instruction. I'll be giving you 5 minutes to finish the activity. Okay, here is the link. You may start now and good luck. Okay, what have you learned from the discussions? Okay, to answer that, please do the activity. Letter A, list 3 things you have learned in the lesson. Letter B, list 2 things you would like to learn more about. And letter C, list 1 question you have in mind. Okay, for our performance task, it is a group activity. You are grouped again into 3. So for group number 1, determine whether or not the distribution represents a probability distribution. Explain the reason why. Rubrics provided below. So we have here 1, and next distribution we have number 2. So we have here the rubric. So these are your score. Your score will be 9 out of 10 if the idea explanation, thoroughly explain ideas. For coherency, extremely coherent writing. For grammar, free of errors. Your score is between 7 to 8 if your ideas explain, coherent writing, there are some errors. The score is 5 between 5 to 6 if your ideas somewhat explain, somewhat coherent, you have many errors, and you need improvement. your score is 0-4 if the explanation is little or no explanation of ideas, lacks coherency, many errors that mislead ideas. Okay, your scores will be based on this rubric. For group 2, determine whether or not the given formula describes a probability distribution. If it does, show the probability distribution. And these are the given. Okay. For group 3, construct a histogram of the following distribution. Okay, we have here 1 and 2. Do you have any question, class? If you have any question, feel free to chat me on our Google Classroom or PM me. Feel free to chat me in my personal messenger. Okay, that would be all. Good luck to your performance tasks. I'll be waiting for your output until Friday. Okay? This would be all. Thank you for listening and see you on my next video lesson.